5 is all about classes, and we covered this material in a lighter way in Unit 2. So everything that we talk about today is going to be like, oh, I remember we did that, you know. But we're gonna, get into it deeper now. So I'll pretend you didn't have Unit 2, but a class is a blueprint or a recipe for an object. And objects have attributes, which are variables, and behavior, which are methods. And we always, to create an object, you have to use the new keyword. And here's an example, the scanner one. So you haven't created an object if you haven't used the new keyword. So whether it's frog f equals new frog or scanner whatever equals new scanner, the new word is what tells you you're creating an object. So think of it as a recipe or a blueprint, and literally it's like you have a recipe for how to make an apple pie, and if you had all the ingredients handy and somebody said, you make a pie, you could follow the recipe and make a pie. That'd be new pie. Pie for Hayes equals new pie. Boom, and it's done. And then you could do another one. The recipe's still there. You haven't lost that. I haven't watched this video in a year, so let's see what it does. All right.
When I found out
we're getting an ad.
was doing career certificates, and they had one in data analytics, I thought it seems like an easy.
Okay, in computer science, we want to model things that exist in the real world, and we're going to use code. Here, we're going to use Java code to model those things. So we're going to have something called a class, which is like a blueprint for an object. So if this dog is my object, it's just a little stuffed dog. You can imagine that I've got a blueprint that's the instructions for how to make a dog. Okay, that blueprint is called a class. So with that class, that's my blueprint. I can make dogs. Those dogs are my objects. I can make a bunch of them, and they all follow the instructions of that class, which is my blueprint. But then I can have actually different ones. So these are different instances of the class dog, or whatever this stuffed dog is that I'm making. So these are objects of that class. And then you can imagine each object can have different attributes. So these are different properties about it. We'll use the key term attribute, and then we'll also use instance variables. So you can see these ones are different colors. And so you can think about those different colors are the different attributes or the different instance variables. So they still use the same blueprint because it's like still the same dog. So they still use the same class, but there were details about them. Those were the instance variables or the attributes. Those were the things that were different between each object of the class or each instance. And we'll use instance and object interchangeably. So this is one object. And then the things about these objects, those are the attributes or their instance variables.
She didn't talk to us about methods. No autoplay. No, stop. Anyway, I don't know where I found that video, but it's somebody besides me talking for a minute. So a class is declared like this: class rectangle or public class rectangle. The thing about the public word is if you use public, then the file that the program is stored in has to be named exactly the name of your class with .java after it. So when we go and look at a program in REPL, this it's not going to make a lot of sense in REPL because you're like, what is he talking about? Files or whatever. Let's look. I'll create a project. Over here on the left, though, we'll see that they have a file called capital M main.java. And so look, this is class main with a capital M. This name has to match that name. And when you say public class something, then it has to have the name. And so I wouldn't worry about the public class. You're not going to get marked wrong on the AP test for not saying the word public. But don't be thrown by seeing it. Sometimes it'll say public, sometimes it won't. when I used to teach this class before we went on distance learning, we did everything programming on your actual computer, and you'd have to save a file. So the file had to be named just right. And so you'd say public class or not. But that's not really something we have to worry about a lot. Classes start with a capital letter. So see the capital R, or capital F for frog, or capital S for student. It'll work if it's not capital, but I want you to get in the habit of naming your classes with a capital letter. The body of the class, all the code inside is inside of a pair of braces, the curly brackets. Inside the class up at the top, we put our variables or the attributes that the video was just talking about. And they're always supposed to be private. And we'll talk about what that means more another day. But if I had a rectangle that had a width and a height as two attributes, how wide it is, how tall it is, we'd just put private in front of both of those things. Instance variables. One of the AP class video lecturers says data members. I'm like, really? But anyway, don't worry about it. I mean, I don't know why you would say that instead of variable. But anyway, it's fine. It's like in the video, you could control the color, or in a way, you could control size or any other attribute we wanted to do. Next in a class are constructors. They initialize or fill in the values of the variables for the class, getting it ready to exist. So here's an example of a constructor. Constructors are always public, and they have the exact same name as the class, and there's no return type. So don't say public void or public string or something like that. It's just public, and then the name of the class. And then they can have parameters or not, depending on what you need. Classes also can have methods which define their behavior, like in a rectangle class. And we've used this actual class that I'm going through back in Unit 2. You might want to be able to get the area of a rectangle. And this is one that would return that. It would just calculate it on the fly. Hey, the area is width times height. Methods can be public or private, depending on what you need. And again, we'll talk more about that another time. In general, make them public, the methods. Methods have a return type. So it's like int, string, double, Boolean, or void if they don't return anything. And they tell Java what that method is going to do. So the method can just do stuff, but not give any information back. That in that case, you'd say void. Or they could hand something back to whoever called them, like a piece of text. Or they can only hand one thing back. They can't hand a bunch of things back. That's that return call that you've seen and used, particularly mostly on CodingBat, right? If you call this method, you get an int back. Here's the word int. And so you could somewhere else print that or store it in another variable. Here's another example, set width. It's a void method. You call it by sending a number to it, and then it updates the width to be this new number. It doesn't return anything because all it's doing is changing the internal variables. Some classes have a toString method, and a toString method returns a string representation of the class. So like frog, if you just make a frog and print it, if you took our toString method out of the frog class, then when you printed a frog, you'd get frog and then some weird number. That's just an internal Java thing. At least they're telling us you tried to print a frog, but that's not very useful. So inside of the frog class, I have a toString method that makes a temp variable and then does a for loop to put the right number of dots for the location of the frog, and then throws on an @ symbol at the end, or now with Johan's improvement, the little emoji, and then returns that piece of text so that you get the pretty thing. So we're going to, in almost all of our custom classes, we're going to do a toString method because we want to be able to print them and have them mean something. So today, in just a minute, we're going to write a custom class from the ground up together for a person class. But first, I want to show you some of the classes we've done this year so far. So I have them all in one, and you're going to have access to it in a second. And then we'll get to work on it. Any questions? I'm calling this the class playground because there's a lot of classes in here. Now, mostly when we've done things like the frog class, I've just put the frog class down below inside the main.java file. But over here today, I put them all over on the left. So these are like separate files. If we had them on a hard drive, there'd be like a folder and they'd all be in the folder together. That's how you can think of this. So main is what's going to run. When we press run, Java's going to go to main and then look for one with a small m main and try to do what it says. And right now, all it does is print empty spaces for all the classes. But let's take a look at book. I don't know why this keeps coming back like that. Book, we have title, author, year as our variables, and there's a couple different, 3 different constructors, and there's a toString. Circle, you may remember from Unit 2, has a radius variable. That's the only attribute we have for a circle is what's the radius. Frog, we've been using Frog a lot. It has a location and has a hop that hops 1 and has a hop n that'll hop as many as you send over. There's get location. There's the toString. The person class is right here, and it's a little bit empty. We're going to do that in a minute. And there's the rectangle class, which has a width and a height and things that you've seen before. So I'm going to want you to look that over a little bit. I'll assign this now, and I want us to make the person class together. So I'm going to assign this. If you could open that class up and fork it, that'd be great. Walker?
What are you going to use a Java file that's got multiple classes in it?
You can name it anything, but the classes inside can't be public.
Okay,
So if you have a Java file, you could call my working classes.java, and inside you'd need it's going to look for one called main to run, and then all the other classes can be in there, but none of them can say the word public in front, because if you put public in front, it won't compile because it's saying, hey, I'm looking for a file named exactly this, and I can't find it.
Public classes have to always be in their own files.
Yeah. Well, you could put other classes inside of one that are not public, but if you have the word public in it, it has to be in a file of that name. So you couldn't have 2 classes that both said public in the same file, because that would be impossible. So I did just assign this class playground. If you could open it up and fork it, I will model that good behavior so I don't do all the work for you. Sorry. And normally I close that little file list on the left because it's not meaningful for a class that has only one file, but here we have all these different things. So let's go to person, and I'd like to do this together. It says above, write the person class. I must have the following: a string variable last name. So right here, private string last name. So everybody do this, please. And just go ahead and, it's right here. And then private string first name, private string cell phone. I posted it. Oh, where is this? Yeah, let me know if you're having trouble finding the person class.
Go back to record. Click on that one. And go to person.
So now we need a constructor that accepts the first name, last name, and cell strings in that order and creates a new person object. So what do we know about constructors? They have the same name as the class and they're public. So public person. And then I said what I want. I'm gonna get rid of the instructions as I go along so that we'll always have the most recent thing close to the top. I want it to accept. When I say accept, I mean right in here in the parentheses, we're going to accept first name, last name, and cell as strings. So don't make it the same names. Let's just do a F for first name, or we could just say first and string last and string cell. So we'll talk more on Monday about what these should be named, your variables, but for today, let's make sure that you use different names than the ones we defined up above. And then every method or constructor has a pair of curly brackets after it. So here's a pair of curly brackets. or braces, whatever you want to call them. And we're going to set the variables to be equal to the things that we sent over. So it's first, last, and cell. So first name equals first, last name equals last, and cell phone equals cell. Now, I often see people reverse this, like to write first equals first name, but that won't work because first name doesn't have anything in it at this point. It's going to be a null variable if you do it that way. Think of it this way: somebody else is calling new person, which is invoking the constructor, and they're sending over a first name and a last name and a cell. And these three variables exist just for a fleeting moment while the constructor is running. And so we want to store their values into the permanent variables, which are private string, private string, private string. Questions? Almost done. Step 5, a second constructor that accepts just first and last name and creates a new person with an empty cell phone. So let's just copy the whole constructor. Copy and then paste it and just get rid of the cell phone. So when I say accepts only a first and last name, that means we're not getting a cell phone. Remember, this is constructor overloading. We have two constructors for this class. One takes all three pieces of information, and the other one, we don't just delete the cell phone. We want it to equal nothing. So put empty quotes there. If you just got rid of that line, then cell phone would be null, which isn't the same as empty. And you don't have to put spaces between the things, but it's easier to read when you do, like between the different. So this is all being recorded. If you need to finish it later, it'll be fine. And write a method, public string get phone, which returns the cell phone. So you can just copy this, or you could type it. But public string get phone, and then empty parentheses. Methods always have a set of parentheses, whether they're accepting an argument or not. And here I want to return the cell phone value. And this variable exists because it's at the very top of the class, pub, private, everywhere. All the methods and constructors have access to these variables inside the class. So but other people don't. So if you were in some other class creating a cell phone object, you can't access those variables because they're marked private. So you have to call a method. If you want to know somebody's cell phone, you have to say get phone, and then it'll return the cell number to you. We're going to use this in just a minute. And then finally, I gave you the toString because I didn't want to turn this into a federal project. So just copy the toString code I gave you and put it up here after get phone. I'm just going to have to trust last year's Mr. Hayes that this was a good idea to just give it to you. But particularly with today being the rally day, I think it makes sense for me to make this part not take this much time. This is checking, hey, if there's no cell phone number, then just return first name and last name. Otherwise, return first name, last name, and then the word cell followed by the cell phone number. So it's just to make it nicer for people that are trying to use this. You could right now say run, and it's going to compile this code to make sure, that'll make sure you don't have an error. Nothing new is going to print because we haven't created any persons yet. So then down here, it does say back in main.java, write the tests that are listed. So let's go back to main. For a minute, let's skip the book instructions, the circle instructions, the frog instructions, the rectangle instructions, and let's get down here to the person instructions. So it says go to the person class. It's an empty shell. You will code it. We just did. Follow the instructions in the person class to write it. We did. Then come back here and create and print a person object using a first name, last name, and a fake phone number. So right here, person P1 equals new person. When you're going to create a variable, you need to give it a variable name. You don't have to use P1. You could use Frankie, but let's not worry about what the person's name is. That's handled over here. But we're going to send over a first name, not Booby, Bobby. That's hilarious. Bobby Hayes is my fake child's name. And there's a cell phone number. And I'm going to print it. And you should too. So if you wrote the person class perfectly, then this will work now. And if there's mistakes, I will walk around and help you. But here's what happens now. Then I want you to make and print some books and a circle and a frog and a rectangle just for practice. You don't have to write those classes though. They already exist, thankfully. And but here I created a person named Bobby Hayes with a cell phone number, and look at prints. And then it says also print just the phone number using the get phone method. So system.out.println cell p1.getPhone. Hopefully this is making a certain amount of sense. If I want to get the phone number from the object named p1, then I have to call the getPhone method on the p1 object, and I'm printing it with a little label so that we can see what I just did over here on the right. And then it says finally create a second person using just the first and last name, and then print that person. You obviously can't, there's no point in getting the phone number on that second person because they won't have a phone. But I'm going to say person P2 equals new person. Bobby with an I is Bobby's fake sister. And there's no phone number for Bobby. And you do your own names. And if you did Bobby, that's fine. I'm sure I told you, like, oh my God, 8 years ago, my younger son filled out some ASB class form with the name Bobby Hayes. And I still get credit card applications for Bobby Hayes at my house because they're thinking, hey, Bobby's out in the workforce now. We should get them to have a credit card. And I guess my son had good grades that year. They're like, A student, let's get him a credit card. It's against the law, by the way, to open a credit card in a fake name. Otherwise, I would have done it because it sounds like a fun thing to have. Yeah, I didn't buy that. Bobby bought it. But anyway, I'm not breaking the law, and nor should you. So folks, that's what I wanted you to do with the person class. But then a little bit more here today is I ask you to look at the book class and then create and print 2 book objects, and then look at the circle class and create and print a circle, and then get its area and perimeter as separate lines, and then create a frog, make it hop your age, and then print it, and create a rectangle and print it, and print its area and its height. So all those requirements will have you use the methods that are already in those classes. So go for it. I'm going to stop the video because I already did this whole thing in another video. But this was, I don't know, a continuation of our notes.